Have you ever opened up an irrigation controller that wasn't working and wondered, should I fix it or just replace it? Modern irrigation systems are designed to make that decision easier. Most controllers and sensors today are modular or sealed, which means replacement is often safer, faster, and more cost-effective than repair. I'm Dr. DeBusk, and in this section, we'll explore how to identify when to replace versus repair control components, transformers, and sensors. You'll also learn best practices for wiring, safety, and reprogramming after installation. By the end, you'll know how to determine when replacement is more practical than repair, follow safe electrical procedures for all controller work, and properly reprogram controllers and sensors to restore full system function. When it comes to controllers, there are a few internal parts that can fail: the cabinet, transformer, front panel, output models, fuse, or power cord. While these components can sometimes be replaced individually, they're rarely cost-effective or practical to repair unless you're working with a large commercial system. For most residential and light commercial controllers, replacing the entire unit is the smarter choice. Even if repair were possible, the time, parts, and risk involved usually cost more than a new controller. Manufacturers also design many new models to be plug-and-play replacements, which simplifies the process and reduces liability for the technician. If repair is truly necessary, always refer to the manufacturer's official training before opening up or modifying the unit. Before replacing a controller, always confirm that the new one fits the user's needs. Sometimes the homeowner inherits a system and wants an upgrade, like Wi-Fi connectivity or smart features. Next, record the current programming and take a photo of the terminal strip. This saves time and mistakes later. Power down the controller at the breaker and follow lockout, tagout safety procedures before touching any wire. For hardwired controllers, check local codes and ensure you're licensed or working with a qualified electrician. When installing the new unit, verify that the mounting template aligns with the existing screw holes, or adjust it for proper clearance. Always make sure the pigtail cord reaches the outlet. Extensions are unsafe and violate code. Ideally, use a controller with a factory-sealed pigtail, or replace the old hardwired unit with one that plugs into a GFCI-protected receptacle for added safety. Sometimes it makes sense to move a controller, especially if it's inside a garage where technicians can't easily access it. When relocating, make sure the new location is accessible, safe, and protected from the elements. If the controller is being moved outdoors, it must be rated for outdoor use. Indoor plug-in models can't be used outside, even with a cover. Any extension of valve wires must be done properly using UF-rated, UL-listed wire that's at least 18 gauge. Every splice should be made with waterproof connectors inside a splice box, and all conduit entries should be sealed to keep out insects and moisture. When mounting, allow enough space for the controller door to swing fully open. Always form a drip loop on the power cord to keep water from running down into the controller or receptacle. The outlet should be GFCI protected and have a waterproof cover that remains sealed even when the cord is plugged in. Finally, consider adding a cabinet lock to prevent tampering or vandalism, especially in public or commercial areas. Transformers are one of the few controller parts that can be replaced, but only when the system allows it. Indoor controllers use plug-in transformers that connect directly to a receptacle and feed low-voltage power to the terminal strip. Outdoor controllers, on the other hand, have internal transformers connected to line voltage and secure inside the cabinet or a junction box. Some outdoor units are fully sealed, which means the transformer can't be replaced at all. Before replacing any transformer, make sure the new one matches the old unit exactly, the same input and output voltage, amperage, and wire configuration. Never substitute a universal transformer. These often don't meet electrical or physical specs for irrigation controllers. Outdoor transformers also need to fit the original mounting space. One more technician's note: if you remove the cabinet door before working inside, it's much easier and safer to reach wiring and mounting components. Replacing an indoor controller transformer is straightforward and safe since it's low voltage. First, verify that your replacement transformer matches the original unit. Then unplug the old transformer and take a photo or make notes of how the wires are connected on the 24-volt terminal strip. Attach the new transformer wires to the same two screws labeled 24V. It doesn't matter which wire goes to which terminal. Either way works. Tighten the terminal screws securely, plug in the transformer, and power up the controller to confirm that the display and operation are normal. For outdoor controllers, the transformer is connected to line voltage, so extra caution is required. Always shut off power at the breaker or unplug the pigtail first and follow proper lockout/tagout safety. Some areas require a licensed electrician for this step. Always check your local electrical code. To remove the old transformer, start by taking a photo of all wiring connections. Open the internal junction box, remove the wire nuts, and disconnect the 3 line voltage wires, black, white, and green. Then remove the transformer's mounting nut or screws and pull the transformer from the cabinet. When installing the new transformer, mount it securely and connect the low voltage wires to the 24-volt and ground terminals. Match the incoming power wires by color, black to black, white to white, green to green, using wire nuts. Replace the junction box cover, restore power, and test the controller to confirm it's working correctly. The power cord or pigtail on an irrigation controller must meet the same electrical safety codes as any outdoor appliance cord. It needs to be labeled SJTW, which indicates it's designed for wet or damp environments. Using the wrong type of cord can pose both a fire and shock hazard. The maximum allowable pigtail length is 6 to 8 feet. If the controller and the outlet are farther apart than that, move the controller or have a licensed electrician install a closer receptacle. Never use an extension cord or a longer power cord to make up the distance. It's unsafe and violates code. For outdoor controllers, always form a drip loop in the pigtail. This simple bend prevents rainwater from traveling down the cord and into either the receptacle or the controller cabinet. Also, since the power cord stays plugged in all the time, it's required to have a full-time waterproof cover that seals the outlet even when the plug is inserted. The output board, also called the terminal strip, is the part of the controller where all the valve, sensor, and power wires connect. Lower-cost residential controllers often have a fixed output board that can't be replaced. If one terminal is damaged, the entire controller must be replaced. For controllers with replaceable boards, the process is straightforward. Always start by turning off the power to the controller. Take a picture or make notes showing which wire goes to which number terminal. That step saves a lot of frustration later. Then remove the wires and the mounting screws holding the board. Some boards use small threaded spacers called standoffs to hold the board away from the back panel. If a standoff starts spinning as you loosen a screw, hold it in place with pliers so you don't strip it. Once the old board is removed, install the new one, reconnect the wires exactly as before, power up the controller, and test all stations to confirm operation. Many modern controllers use output modules instead of a single terminal board. These modules control groups of stations, and replacing a bad one is much safer than rewiring the entire controller. Even though some manufacturers say you can replace modules with the power on, it's always safest to turn the controller off first. Then, just like before, take a quick photo of the wire connections before removing anything. Disconnect all wires, then unlock or unsnap the old module. It might have a screw, a retaining clip, or a ribbon cable connection. Insert the new module, secure it in place, reconnect the wires to the same terminals, and power up the controller. Test all stations to make sure the module is working correctly. This simple replacement restores full functionality without having to replace the entire controller. Every irrigation controller has a built-in safeguard to prevent overheating, fire, or electrocution from excess amperage. Depending on the model, it may have a fuse, an internal circuit breaker, or a resettable breaker. If your controller has a fuse, replace it only with the exact same type, voltage, and size. The best way to verify the correct fuse is to check the owner's manual. There's no such thing as a temporary fix for a blown fuse. Never use wire, foil, or a penny as a replacement. Doing so can cause serious damage or even fire. If the controller has an internal circuit breaker, it will automatically shut off the overloaded station or pump circuit and display an error message, often called a skip station alert. Remember, clearing that message doesn't solve the problem. Always identify and correct the issue that caused the overload before restarting the controller. Some controllers include a resettable circuit breaker instead of a fuse. When overloaded, the small button pops out. Simply press it to reset, but if it trips again, stop and troubleshoot the underlying fault before continuing operation. Rain sensors are the most common type of irrigation sensor to service because they're exposed to weather, debris, or sunlight year-round. Over time, pollen, dust, or splashed gutter debris build up on the discs, reducing how accurately the sensor shuts off the system after rainfall. The most frequent repair is replacing the disc stack. Most manufacturers recommend replacing it every 3 to 5 years, and some contractors include it every 2 to 3 years as part of their service contracts. Disc stacks are not interchangeable between brands, so always order the correct part. Replacement is easy. The old stack simply unsnaps as a single unit, and the new one snaps right into place, or alternatively, you can replace the cork discs. If your model has 2 disc stacks, remember that only the main, large stack can be replaced. The smaller stack immediately shuts off irrigation, but isn't adjustable or replaceable. Relocating a rain sensor is one of the most common field repairs because the landscape changes over time. Growing trees or new structures can block sunlight, wind, or rainfall, preventing the sensor from working properly. Also, when homeowners try doing it themselves, it ends up in some interesting places, like the photos show. When moving a rain sensor, choose a location that's open to rain and sun, not under trees, roofs, or eaves. Keep it far enough from sprinkler spray to avoid false triggers and in a spot protected from vandalism. Wireless sensors make relocation much easier. Just be careful not to exceed the transmitter's range and avoid interference from metal roofs, transformers, or other electrical devices that can block the signal. If you're moving a wired sensor, use proper wire gauge and waterproof splices inside a splice box. 16 gauge for runs up to 100 feet or 14 gauge up to 200 feet. For longer distances or to simplify service, it's often worth upgrading to a wireless model altogether. Wireless rain sensors require very little maintenance, but when parts need to be replaced, pairing is key. Each transmitter, the part outside that measures rainfall, has a unique address. When installing a new receiver, follow the owner's manual to pair it with that transmitter so communication is restored. Most wireless sensors use lithium batteries designed to last up to 10 years. You can check battery strength using a small test button on the sensor or by looking for a signal strength or battery icon on the receiver display. If replacement is ever needed, follow the manufacturer's directions carefully. To protect your investment, use available accessories such as protective cages for the sensor and enclosures for the receiver. These guards prevent vandalism and shield the components from branches, debris, or accidental impact. Soil moisture sensors can get damaged or need to be relocated because they sit right in the turf's root zone. Whenever you install or move one, it's best to follow the manufacturer's directions so the readings stay accurate. Placement is everything. Aim for a spot that represents the average soil conditions in that irrigation zone, typically in full sun where the turf dries fastest. Avoid low or disturbed areas, edges of driveways, or gravelly soil, since these can cause false readings that throw off the irrigation schedule. The program inside a controller or sensor is what tells the irrigation system when and how to water. Just like a computer, these devices are only good as the information we give them. When a system isn't running as expected, it's not always a mechanical issue. It might just be a programming problem. Reprogramming ensures the system applies water only when the rainfall cannot, only when plants truly need it, and using the least amount necessary for healthy growth. Everything we discussed about controllers also applies to programmable rain sensor receivers. These have simpler programs, but they're just as important to keep accurate. When reprogramming, there are 2 key parts: knowing what information belongs in the program and knowing how to enter it. First, technicians need to understand factors like how long plants can go without water, when watering is allowed by local regulations, how much water the plants need, and how quickly the sprinklers apply that water. The best irrigation program is built on this understanding. It blends plant science with system performance. Next, you'll need to know how to enter that information into your specific controller. Every model has its own steps, but thankfully, nearly all manuals can be downloaded digitally. If a controller has confusing or conflicting settings, especially when multiple people have made changes, the fastest fix is often to reset it completely. That clears all programming and returns it to factory condition. It may sound drastic, but it's usually quicker and more reliable than trying to untangle a messy program. Always refer to the manufacturer's instructions for how to perform the reset on your specific controller. When it comes to irrigation controllers and sensors, the key is knowing when to repair, when to replace, and when to reprogram. Always start with inspection, clean and test before making your decision. If a component is sealed, corroded, or obsolete, replacement is usually the safest and most cost-effective option. Follow all manufacturer guidelines for wiring, grounding, and installation. Keep sensors clean, properly placed, and connected. Then make sure the controller's programming reflects your system's current conditions. Accurate timing and watering schedules can make all the difference in efficiency and plant health. Ultimately, our goal is to maintain systems that are safe, efficient, and responsive, so every drop of water serves their purpose. Finally, test your repairs and document everything. Clear records protect you, your company, and your clients.